All right, so now we're going to repeat that experiment, but this time we're going to use the vacuum pump to pull close to a vacuum in the low pressure side of the chamber. So what I need to do in order to do that is select this knob here to vacuum out. I need to select vacuum shut off with this lever here, and I'm going to start to run the vacuum pump out. Okay, so now that the vacuum pump has been running for a couple of minutes, I'm just going to go back over and check to see what the pressure is in our low pressure side of the chamber. I'm going to shut off the vacuum shut off to stop the air from leaking out. And I'm going to use the vacuum check button to check what pressure we have in the low pressure side. So what do we have? That's 16. Remember, this gauge is reading in inches of mercury again. We have 17. I'm waiting for the needle to stop. Got about 17.5 inches of mercury. Okay, so the other thing that I need to point out here is that by applying the vacuum pump to decrease the pressure in the low pressure side, it's actually triggered the oscilloscope, right? So we need to reset that up to a single record, keep the trigger settings exactly the same as they were for the first experiment, and now I can go ahead and basically repeat the process as we did for the first experiment. So I'm going to feed in to the high pressure side air from the wall, and then go ahead and open up the valve, and we'll see the pressure increasing again. So the point here is that the disc separating the two sides of the chamber should break at the same differential pressure, right? But now, because the low pressure side is below atmospheric pressure, we should see the disc burst at a lower pressure on this test gauge here. But the point is here, the shock wave will travel at a faster speed down the shock tube. So I need to select pressure in here. My valves are both closed. I'm going to go ahead and open up the wall tap. Now go ahead and open up the needle valve. You can see the pressure increasing on the high pressure side. That's 15 psi, 20, 25, 30. So this time the disc broke at approximately 38 psi. And you can see we have an output again on the oscilloscope.
All right, so just like on the run that we had previously with the low pressure section atmospheric pressure, we have successfully triggered and captured the event. If we look at the oscilloscope output, we're going to see the same type of behavior as what we saw before. We're going to see our initial shock wave, and then we're going to see multiple reflections. So again, we're going to have the raw data later, but just to kind of get some ballpark numbers, we're going to go through and we're going to look at an estimation. So if we look at our horizontal or our time division between the wave passing our first sensor and the wave passing our second sensor, we can see now that we have an estimate of about 1.1 milliseconds. So that indicates that we have a faster wave speed than what we had in the first case. We could also estimate our amplitude rise of our wave. And if we do that, we see an amplitude rise of about 43 millivolts. At this point, we're going to save the data. We'll save both the image as well as the raw data, just like we did in the first case, so that you'll have those available on Canvas. And with that, that successfully wraps up our shock tube lab.